So after assigning this location, now elevation at the layout line. So the global Z direction. So this will be the location of the bearing. So as with this is bearing substructure location. Now the bearing location. So the bearing is in the location. This is the location of bearing. So previously it was from here to the top of this bearing seat. Now it will be from here to the top of this bearing pad. So the bearing pad is, I believe, 50 millimeter. Let's say it's 50 millimeter. So 1552 subtracting 50 from this will give us minus 1502. So this is the bearing elevation. So after defining this bearing elevation, the bearings are straight aligned with the aligned with the bent. Uh, After defining this, okay. So after defining the elevation of the bearing and the bearing pad, sorry, the bearing, the bearing and the bearing seat. Okay, someone, can you repeat? Yes, I will. Okay. So this was the location of this bearing. You see, this was the location of the first one was the location of this substructure location refer to this point. So substructure location refer to this point, the top of this bearing seat. The other option is bearing assignment elevation at layout line Z. So this refer to the uh, height of to the bottom of the bearing pad. So this will be this height from the top of the deck to the bottom of the girder. So this is this height to the bottom of the girder or to the top of the bearing pad. So this is 1402 plus 225, and it comes out to be 1402 plus 225. Yes. No. 1402 plus 225 minus 75 this and minus 50 this. So it comes out to be 1502. Dar Saab, did you 1502? Yes, so you got it. So it's good. So now after defining these all bearing location, you have to define the what is the property of the bearing. So at this location, you see at the start bearing, if I go to the plan of this bridge, at this is the plan, this is the plan. So at the start of the abutment, what is the support condition? So it cannot move transversely due to these shear key. These are the shear keys. It cannot move vertically due to these supports due to the abutment, and it cannot move along the layout line due to these pins. So it has been restrained in the three direction. All the three translations are fixed. Yes, good. So that you can define if you have had defined bearings previously. So if you had defined bearings previously, start bearing I had it. So modify show. So you see that all the three are fixed. So if you have defined it previously, you can select it from here, or if you haven't, so you can click this plus and you can define it again here. So I will select the start bearing. Now the end bearing. So the same definition will be end abutment. All the other options are same. We have abutment property. I had defined it previously. The same. It has the same elevation 1552, and the same 1502. Similarly, the bearing. I will see what is the bearing. Okay, so at the end we have, I believe, So the end abutment is not given, is not shown here, but you can see that at alternate span we have these pins. So here we have these pins, here we don't have these pins. Similarly here we have these pins. So and at the end abutment we will have uh, we will have no pins. So in this drawing I think it is not given. So pin, so let me zoom into this drawing. So here it will be pinned, no pins, in this pins and no pins. So this is just like a simply supported beam. So this will be, the previous one was start bearing, so I defined it for start abutment bearing. So modify show bearing. So you see that fixed, and this along the layout line we don't have any pins, so it is free. Okay, so the rest of the data is same, so I will select OK. So after defining abutments, I will define the bend properties. So the bend is, when you click on the bend, so we have only single span. So if we have multiple span, then you have to select a span from here. So span number 2 is the span in which the bend lies. So this is the, we have two spans, span number 1 and span number 2. So bend at the end of this span. So bend is at the start at this station. This is the location of the station. So this we have defined in the bridge object. Bend is at the end of this span. So during the span definition, I made a mistake that so the first span is, you see the first span is named as span 2 and the second one is span 1. So if I, let's say I modify it, let's say it is span 1, modify, and this is span 2. So it will now be corrected there, modify. Okay, so now when I come here, bends, so bend is at the end of this span. So it is at the end of span number 1. So span number 1 start from start abutment and end here. So this bend is lies here. So all the this referred to, so superstructure assignment. So diaphragm property. So I had so as you know that we have diaphragms here as well at the bend location. So I will assign diaphragm here. Diaphragm property before and after. So you see that we have two diaphragms, one here at the start and one after this one. This, so we have two diaphragms, so we have to define two diaphragm here, diaphragms. So after diaphragm property, after diaphragm property, before this refer to the center line of the bend. So before the center line we have one diaphragm, and after the center line we have other diaphragm. So this is the first diaphragm, this is the second diaphragm. So if you are not getting anything, you can ask in the, ask me. I am just continuing. I cannot see your chats. So restrainer, as I told you that we have no restrainer in the RC bridges. Now bend assignment. So I have defined this multiple column bend. So multiple column bend. So I will select that one. Bend direction, as I told you, if you are using a skew bridge, then we will have this. We can define an angle here, and the location for the location for the bend, and the same location that we define for this this location, the location of the bottom of the girder and the bearing are same both for the abutments and the bend. So I will use the same location here, 1152 and 1502. 15, so this is in meter, so let's 1.52 and 1.502. So as I told you that we had defined previously two discontinuous structure or two bearings length. So if you define two bearing length, then there will be two options. So if you have a bridge, a step in which we have a step type of transom. So for example, if we have a bridge in which we have a step type of transom. So for example, this is a, let's say this is a, suppose span which is 40-meter long, and this is a span which is 30-meter long. So in that case, the depth of this span will be different from this one, and in that case we will have a step type of transom. So we can have a step type of transom in that case, such like this. I will show you a step type. So in that case, you can define these different elevation as well. So for that, you have to define these different, you can define different elevations. So in our case, we have the same superstructure. So I will use that, the same definition for both the bearings. And as I told you that the first one was pinned, and here we don't have any pin. So this one will be this one will be simple bearing, because in the bearing we have the translation free. So pinned, not pinned, pinned and not pinned. So the first one was pinned, so I define it in the start abutment. Now this is not pinned, so I define it by bearing. So and this one will be pinned, so it will be start abutment, start bearing. So start bearing, or you can rename it to pin. This is how you will define the support condition. So let me repeat again. So the first one was pinned, so it was a hinge type connection. The second one was not a roller type, so this is the roller type. The third one was a hinge type, so this is the hinge type. Start bearing was a hinge type, and the final one was roller. So I had defined this roller in the end abutment. So you have to give due consideration to the support condition. After clicking OK, so your supports and superstructure had been assigned. So the T-beam has been, so then you will come here and update as an area object model. Okay. So you see our structure is defined. I had made some mistake for in the support assignment. So let's come here again. Sorry. Sorry. So I told you in the, I have selected the wrong one option. So I will come to this one how. So I will select this abutment and abutment. Now, okay. I don't know what is the problem here. Foundation springs. So sorry. What is the issue you were struck with? So I got it. Sorry. I was just, I did a, committed a mistake. So I, I am explaining it to you. What is the issue I am struck with? Sorry for that. So abutments, 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 abutments. Okay. I don't know what is the problem with this. So basically I am stuck with this thing. So this thing. So this is, it's showing me this beam. I don't want to define this beam here. I just want to define these springs. So we have options here. So abutment, foundation spring, it is fixed, so it is okay. Okay. Bridge supports abutments. Modify show property. So it should, these beams should not be present here. But I don't know, it is showing again and again. So I don't get why these beams, I have removed them from the abutment property, but let's, okay. So clear all from link model. So the software is giving some, I have cleared all these things, but it is still showing some of the definitions. So the software is stuck with this. So let me close this and open it again. Click all, I these are some of the software issues. We are using the correct version, so it will happen. No, I will open this again. So supports abutments. Okay, so abutments, foundation springs, just like the previous one. Now update it. So you see, I was doing this. So for example, if you define these foundation springs, so it will just connect, it will just uh, draw this single point link and connect the bearings to these links, so you don't have to define the beam. But if you want to define a beam here as well, a transom type beam, just like this one, just like this, if you have a beam here just like this, so you can do also that as well by selecting this components abutments. Instead of foundation spring, you can select continuous beam, and if you have defined any section, so that you will select transom. So I will select transom. Similarly, I will update it. So you see now we have this beam. So previously, if you define foundation spring, so this beam will not appear. But if you define uh, mm, this beam as well, so this beam will appear. So you have these two options as well. So the first type of option is that if you have simple type of abutment just like this, so you can define the beam explicitly here. But if you have complex type of abutment just like this one, this counter force type of abutment, so in that case you can model these link element and you can extract the link forces and create a separate model for the abutments and apply the load there and analyze them separately. But if you have simple beam type of abutments and you have a rocky strata where you can support them, then you can define this beam explicitly. So this is how you can do this uh, by doing this, either foundation spring or beam. So if you select a beam, then you have to define the beam and the beam length here. So hope you got this, what I was doing and what I was trying to doing, but software was giving me errors. So this was all about bends and abutments. So okay. So if you have any question until now, so we can discuss.
I I had asked about the drawings because to practice this one, is it possible for us to get just a PDF of the drawings and the documents?
This drawing I have shared it, sir. I believe in the first lecture I have shared it. I shared it. If you
Okay,
go, if you go to the folder, in the first lecture, I have shared this.
okay,
Yes, so it is present. It is present in the folder. I think in folder number 1, lecture number 1 or lecture number 2. You can check there.
okay, thanks.
Support items and
Aziz, are we finished? Are we finished with the lecture or anything else?
so if you guys want me to continue, I can continue
No,
because
no, that's. I think that's enough for today. I
yes,
think we
it is
can.
enough. I think it is
This
enough.
will.
Yes, yes, I believe it's enough. I believe it's enough.
So
Yeah.
the remaining part of this lecture is, let me go through it. So after I had defined this, you have seen, I think you have got what I was trying to do with this these thing, but the software was creating some problem. Then I restarted it. So the basic purpose was that you can define beams here as well explicitly, and if you have complex type of abutment, then you can assign links here, and you can extract the forces. Uh, uh, should you should try this one as well tomorrow, or you should try this one. If you can't do it, and I will do it tomorrow, and tomorrow we will also try to model these piles and foundation in the CSi. So tomorrow we will concentrate on the defining piles and the pile caps in the CS. So it will be just to definition. So it will not be a detailed discussion about piles, because B foundation is also a separate topic, but I will show you how can we define these in the software, and how can we extract the forces and the reaction, how can we uh, extract the forces for the detailed design of substructure elements. So this is enough for today. If anything else, so then I can answer. If no, then we can start the session.
This pertains to my email. When is a good time for me to call?
Could you all good, clear? So yes, okay. So bye, thanks. Okay, sir, bye. So stop sharing. I will also stop recording, so we can